Using solver on your calculator will be really useful going forward in this class. There's a couple of key equations that will sort of come up again and again that it will be useful for the homework or even for an exam to plug into your calculator and throw into solver. I never really used this, but it's really convenient for some of these key equations. So I'll just show you how this works on this TI-84 over here. If you need help using it on your calculator, let me know. But I really don't know why I never really used it before, but here it is. So in the TI-84, it's under math, and then when you click math over here, click math, and then you can scroll all the way down. It's the very last thing here under solver. And first we write the equation. So in this case, I'm going to want to plug in the Boltzmann equation. To make that work more easily, it needs to be some calculators you can plug in both sides of the equation separately. In this one, you need to solve it so that one side equals 0, so we can just move everything over to one side here. So in this case, I have n over j and I over nj there, and just subtract that from both sides. When you do that, you should get an equation that looks like this: 0 equals ni over nj minus e to the minus delta ej over kbt. I'm going to plug that in. I'm going to use n and m for these levels. I guess I could use I and j here. I'm going to use this form right here. I'm going to call the two level populations n and m, the energy E, the Boltzmann constant capital K, and T, just capital T. So I'll type that in here. When I get to this last part, remember I need parentheses around that K times T because it's in the denominator. Okay, so now I have my equation entered in. And then I can go in and plug values in here. I'll just delete all these and start from scratch, but you can plug in, let's say I want 0.1, let's say I want this ratio to be 0.1, and I want to determine the energy difference in that case. So I'll plug in my K, 1.381 times 10 to the minus 23rd, if you remember that value of that constant, and then I can just scroll to E and click enter, click solve here, alpha, and then the enter key to solve. And so in my case, this gave me an error. One thing to note is that you do want your guess to be somewhat close. So I just changed my guess to 0, and now it was able to solve it. 9.48 times 10 to the minus 21. So it's pretty easy to go in and change, if I cared about when the population difference would be 0.5 for one level compared to the next, I can just go back in and click solve again, and it'll tell me 2.85 times 10 to the minus. If I want to change to doing this in kilojoules per mole unit, I can change my value of K to R in kilojoules per mole, so I could plug in 0.008314, the value of R in kilojoules per mole, and now this will give me that energy difference in kilojoules per mole if that's a unit that I like better. And so now the ratio is 0.5 when the energy is 1.7 kilojoules per mole. So that can be quite useful for some of these key equations throughout the class to let you quickly solve these different equations under these different scenarios. That guess is sometimes important. The other thing that can cause problems is the bounds. Make sure the bounds are large enough for what you're trying to solve.